Okay, question number 16. That's from calculation of magnetic field. We need to apply Biot-Savart's law. More specifically, we have a ready-made formula for that. There is a hexagon and the side of the hexagon is given. I'll be calling it by L. The number of turns, that's also been given. And we are asked to compute the magnetic field at the center in units of this much. So let's see. And in order to do that, first we'll begin with expression. So this is the hexagon and the length of the hexagon, the side that's given, one side. After that, what we'll do is see, let me just make some additional diagram here, and it's something like this. That will act as the circumradius, okay? That's a given point. And together, I would also be requiring another one. So these are the variables I would be requiring. Okay, now the calculation begins. So it's a hexagon. So quite obviously, this is going to form an equilateral triangle, right? So even this will be equals to L. And this, let me call it as R. And then this particular angle, that's straightforward, will be 30 degrees. So now it's time we begin. First of all, I'll calculate the field due to one segment. So how much is that going to be? Mu naught I by 4 pi R, and R is going to be L cos 30 multiplied by sine alpha plus sine beta. So alpha is this, beta is this, so that will be 2 sine of 30. Now just be careful. This is the magnetic field due to one segment. We have 6 such segments, and due to each segment the direction of magnetic field, that would be same. So of course we will be multiplying by the number of segments, that is 6, and together there is also a number of turns. So let me represent that by n dash. So n, of course, that is equal to 6, the number of side, and the number of turns that has been given, and let's see how much is that. Yes, that's 50 turns, so n dash will be 50, and that is the value of magnetic field. And the calculation is not hectic at all. You need to compute in terms of unit of mu naught I by pi that has been given. You do that, you will get option number 1 as the correct option. That was about 16. Now let's go with question number 17. Question number 17. A balloon filled with helium suddenly bursts. Now you need to understand there's a sudden process. So there would be dissipation involved. It's not a quasi-static process. Therefore, there's no option of reversible at all. So this option and this option would be eliminated. And a sudden bursting. So there would be no time for exchange of heat. So that's going to be irreversible adiabatic. Let's go for the next 18th. And here is question number 18. Now there is a screw gauge of pitch 0.1 centimeter and 50 divisions in the circular scale. So how much will be the least count? That is going to be the pitch, which is 0.1 centimeter divided by 50. That's how it comes. And this value of pitch, of course, will be equals to 0.002 centimeter. Now this is a very beautifully framed question. A little bit of common sense is required. Nothing other informations have been given. But one thing you know, with a scale of this least count, the reading should also reflect that. Now the reading can be in the step of 0.002. So of course this can't be, this can't be, this can't be. So of course only option number 1 is the probable. So option number 1 in our case would be the correct one. All about the idea of least count.